Good? All right. So start the time, I'm gonna keep it short. So this is week 2, and we're starting with chapter 2, which is talking about electricity. I'm going to go to some science about electricity and how it works. You don't have to remember all these things, just to give you an idea of what we're working with, and what is electricity, and what's happening in these wires. And because you don't see it, you don't feel it, well, if you touch it, you'll feel it. Usually, it's really hard to understand. So, the relationship between physical objects and electrons, we'll talk about that. What is electricity? What is it? Secret force over there. Why do we need to know and understand electricity? Well, first of all, because we're working with it. If we don't understand it, how are we going to fix it? How are we going to measure it? It's kind of a secret force. 4 types of electricity generation. How do we generate electricity? We talked about that. What are the most 4 common ways to generate electricity? Maybe one day you will come up with a new one. There's always areas of improvement. There's always some genius coming with something, you know. There's always, seriously, if you follow some science journals, there's always good breakthroughs here and there. So when you know about something, you can improve on it. We'll talk about conductors and insulators, which also mean called non-conductor. What are they, and what makes them non-conductor? I would say most of non-conductors are made of what material, what atom?
Non-conductor, you said?
Plastic and
Carbon.
That's good. What element?
Carbon.
Carbon. So whenever things has carbon, probably they are insulator. So what is hydrocarbon? That is
Water.
hydrogen and carbon,
Oh.
which is what? No.
oxygen.
Hydrocarbon. No.
No.
Listed H2O, that's hydrogen and oxygen. Hydrocarbon is hydrogen and carbon, that is all the petroleum products. Hydrocarbon. So you always hear that hydrocarbon. They talk about that a lot. They will ask you this question in the oil burn exam. All petroleum components or fossil fuel components are composed of what 2 elements? Hydrogen and carbon. Hydrocarbon. Depending on the configuration of the carbon atom, this is what makes them different. Gasoline, diesel, plastic, rubber, how do they bond? We'll talk a little bit about that. Did anybody take any chemistry in high school? Chemistry, okay. So you have a little bit of idea of, does anybody know what the periodic table is?
Yeah.
Looks awesome. I know some people have it tattooed, but it's interesting. So we'll talk about this. Okay, this is, what is this? It's a simplistic image of an atom. So for our intended purposes, we know the atom, this again is the big picture. Even though it's very small, you don't see it. This is the big picture. Nucleus has the proton and the neutrons and electrons. So there is a, we're not going to go too deep into it, but let's talk about charges. Do we know what charges are electrons? Eric? Negative charges. Do we agree? Okay. What about protons? Positive. So protons are positive, electrons are negative, and they are the same numbers, mostly. There's some extra, we'll talk about the extras later on. Neutrons? Neutrals. And neutral. So what gives the atom its weight?
Proton.
The protons. What gives the protons their weight? We don't know. We still don't know. So this is a simple atom. It has 3 electrons spinning around it, orbiting the atom at the nucleus, and it can be more. It could be 3, 5, 7, so on and so forth. And every electron has its own orbit, as you can see, and can get bigger and bigger based on the amount of number of electrons and the gravitational power of the nucleus. If you think about kind of the Earth and the Moon, like 1 electron spinning around it, Jupiter has 3 or 4 moons, I'm not really sure, but bigger planets have more moons. So let's think about it this way. We have electrons moving around, and that will give the atom its energy. So far, so good as a concept? Okay. So when we look at the periodic table, somebody just, of course, didn't exist this way, but somebody tried to organize and find the relationship between those materials and those elements and Earth, and they keep finding new ones. Used to be 113, now it's 117. They keep finding new ones currently. So it's organized based on the number of electrons in the last orbit. What do I mean by that? So in a picture we saw about the atom, is the nucleus, and we have orbits around it. 1, 2, 3. Some of them have 2. So based on the number of electrons in the last orbit in the atom, these things has been organized. So this has 1. The charge is 1 here, 2, 3, and so on. And this also has 1. They transition in the middle here. So here we have gases. Oxyhydrogen gases here. And in the middle here we have semiconductors, and metals are in here. So if you look at gold, this is copper, this is all the metals in here. Iron, copper, those are metallic objects. These are gases, noble gases. They have 1, this also has 1. You don't have to remember all this. And if you look at the carbon atom, here, that's 4. That's in the middle. So 1, 2, 3, 4, it has 4 electrons in the last orbit. Okay, why do we need that? We don't. For us, we don't, but we need to understand that there are conductors, semiconductors, and insulators. So here we have our carbon atom. These are the semiconductors, which they can conduct sometimes, depending. And these are the metals, which are very good. They have very good conductivity. Okay, I don't want to scare you or anything, but what we want to think about is the last electron in the last orbit. That's all. This is what makes electricity. And if you can't visualize it, this little last electron can be knocked out from one atom to another. So it's loose, it can be knocked out. And that's what gives it the charge. If you charge it enough, it will jump out. So we can jump it out, yeah.
So metals are the biggest conductors?
Yeah, the best conductor metals. Because again, they have good mass, and they have more loose electrons on the outside. And one of the best conductor is gold. It can give and take electrons very quickly.
Yeah, because
So-
isn't it like gold and then copper and then silver?
Yeah,
Because it's like the most.
the number of electrons.
Yeah,
okay,
so it's like gold, copper, and silver.
And if you look out in here, probably you'll see it. Where's gold? Gold is AU. I forget where it goes. Where is it? This is copper. This is silver, and this is gold. So you see the order? So this is gonna be more conductive.
Yeah, because doesn't the copper like over time, like when you touch it, it breaks, and the copper, copper, like when you touch it, like if it's old and you touch it, it's gonna break and stuff like that. But gold like lasts longer.
I think maybe you're talking about the ductility. Some of them are softer than others, but they all have high ductility and fatigue. If you take a piece of metal and you over and over bend it, it will break. It has different kind of bonds. So let's switch from this into the number of elements was 110, now 118. Every element has different mass, charge, and number of electrons. So the charge is depending on the number of electrons in the last atom. What's a molecule? Benny? What's a molecule? Is water an atom or a molecule?
Molecule.
Yeah, molecule. Because a molecule is more than one atom. Simple. Yeah. So not a lot of elements exist by themselves. You're not gonna find oxygen by itself. If you look at it, is there an oxygen element? No. There's an oxygen atom. That's why when you see it, it's O2, right? Two of them. So molecule is always more than one atom. Okay? Simple. H2O, that's water. 2 atoms of hydrogen and 1 oxygen. That makes a molecule. CFC, chlorofluorocarbon. That's what we used for refrigerant. Again, it's a molecule. It's a combination. Chlorine, fluorine, and carbon. You don't have to. You will know that actually when you take your EPA exam. And CHCF. You don't have to remember these things. Seriously, who does have the capacity for that? But I just want to give you an example that these things are a combination of more than one atom. Question, so elements, molecules, charges. What I want you to remember is the charge. Electron is what we thought thinking about. Electron, electricity. energy in the atom. This is our energy of the atom. The atom mystery is in the nucleus, but this is the energy around it. And everything is spinning. Everything is spinning. The protons are spinning, the neutrons are spinning, electrons also are spinning. So everything is in spinning motion.
So the more electron, the bigger the charge.
Yeah. Also, that's what causes decay. Sometimes this decay happens over time, sometimes over millions of years. So, over time, one of those electrons will fly off, and the material starts to decay slowly. That's why we do something. Have you ever heard of carbon dating? When you watch any of those ancient documentaries, and they say we carbon dated this bone, and we found out it's 400,000 years old, etc. So basically, they trace some kind of decay, and usually in radioactive material, and try to find how much of it lost over the time, and this is how they can find how old. Within a ballpark, of course. They tell you like 100,000, 200,000, or something like that. So decay is something inevitable. Things will always fly off, and nothing lasts forever. And again, the whole thing is just a bundle of energy, and we're just tuning up to it. Conduction. It depends on the number of electrons in the last orbit. The number of the outer orbit is the outer or last orbit. Silver and copper has 1, which is a very good conductor. Insulators have 4 or more. Those are insulators. So we said, based on the periodic table, carbon was in the 4th column. So this is the carbon atom. It has 4 bonds, which makes it very stable. And this is CH4. Now we can make a lot of bonds and a lot of combination of that. So carbon atom has 4 bonds. So we can do again C. This is hydrocarbon. It's very stable, carbon-based, plastic, rubber, organic matter are all hydrocarbon. They can have, they can have single or double atoms in the last orbit. And usually electrons have negative charges. No, they are negative charged. So electricity is a flow of electrons that are negatively charged. So that's why when you have a battery, the flow will go from the negative to the positive. Negative charges like the positive. Electrons, they have no mass. The charge is negative. They have a field. So the field is within their orbits. First orbit will take 2. Second one will take 8, I think 18, 32, bless you, 32, 18, 8 and 2, so it fills up quickly. So the last orbit can take up to 18 electrons, but so it's never full. But depending on how many electrons you have, it can go all the way to the Q orbit. But usually we don't go this far. Yeah.
Don't electrons have mass, but it's so small we don't worry about it?
I don't think they have mass, just a charge. They don't even know what have mass now, not even protons. If you go to deep into it, they know they have mass. They assume for the longest time they have mass, but they don't know what gives it mass. We just know it has, and we're just gonna go with it. It's beyond me how they measure these things, to be honest, but that's what I take at face value. Field frequency. Electrons have frequency. What is the frequency of electron? When you think of frequency, what do you think of? Like something like oscillate back and forth, vibration, right? So frequency is for what is the frequency of electron? How fast is it spinning around itself and around the nucleus? So let's think about it from another point of view. I want to give you something really mind-boggling as well. When you heat a piece of iron, what are you doing? Heat is energy, right? You're energizing it more. You're making the electron spin more and more, right? Eventually, what color it's going to be? Red. This is how much energy it has. Then it becomes white. This is how much you heat it. Then you heat it some more. What happens? you're breaking the bond between the electrons and start to melt. You heat it some more. The electrons have more energy, they're vibrating so high, they start to evaporate. You can evaporate metal at the right temperature. So it does happen. And what happens also when you heat the metal until it's really hot or white color? You don't just look at it. If you feel the heat coming off, it starts to radiate. It's how much energy is vibrating with that you can see it through vacuum. You can feel it through vacuum. You can feel it through air. This is how much energy it has. So energy is what we're giving energy to the electrons. They vibrate faster, and this is what happens to it.
I got a question. So, like, for example, if one of the bolts is like hard to take off in
Yeah.
boiler or AC, but you like kind of heat it up like real good, and then like. put
No,
it in
it
cold.
depends. It depends the situation. Usually,
Yeah, and this it depends
Yeah, it
on
depends.
it. But if you
Yeah.
you're able to in that situation, you can heat it up and cool it off.
Yeah.
And you hit it, and it just comes right off because it's like you heat it up and then you freeze what's going on there. And then
Yeah, so
it just pop.
That's a good
pops
point.
off.
The heating and cooling will expand and contract, and this is another characteristic of these metals. Okay, we'll stop here.